Hello everyone. I hope you have had a wonderful weekend so far. Today's discussion will mostly focus on Lab 1 and Lab 2. So essentially, this week's lecture, which means that I'm going to post two lectures online for you guys, uh, is going to be about Lab 1 and Lab 2. As far as the theory goes, we don't have that much theory left for these two lectures and these two for these two labs and these two labs in general are not very theory focused. They are mostly focused on the flying of an aircraft. So we want to make sure that you have an idea of how to fly an aircraft essentially. So lab one, I'm gonna write here that I will delete it. So lab one, you will get to fly an airplane in a flight simulator. Okay, and you will also learn how to export data. And by data I mean the lift coefficient, drag coefficient, lift to drag ratio, and angle of attack. Okay, so that's your job for lab one, and you have to be able to take off and land. Okay. But for lab two, and this is something that we are going to discuss today, is that you will modify an aircraft. Okay. And by modification, you will see later on, by modification I mean like change the length of the wings or the sweep angle or something like that. We usually deal with Cessna 172. Okay, it's one of the most popular airplanes out there. And then you export flight parameters again. Okay, and then in your lab report, which you have to submit in 2 weeks, 2 weeks from 2 weeks from Monday. The dates are on the syllabus, and if they are not, please let me know. But they will definitely be on Blackboard. Everything. Yeah, in 2 weeks you have to submit your lab report online. I will essentially add an assignment, lab report assignment on Blackboard, in which you can submit your lab reports. And in your lab report, you will see the lab instruction. I will upload the lab. Make sure to read the lab instruction before coming to the lab, and they will be uploaded on today that I'm recording this video, which is Sunday. It is Sunday, August 30th. Yeah, so they will be uploaded. So make sure to read that. But what I want you in your lab report is gonna be on that. I will also upload a rubric for your lab reports. What to include in the lab report, essentially. You just have to make sure to follow that as well. So yeah, and make sure to ask any questions you may have. So this is going to be the general information about the labs, lab 1 and 2, which are pretty connected. And these two labs are also connected to your final presentation. For your final presentation, you essentially have to design an airplane and fly it. or I mean, take one of the design airplane and do a very huge modification and change everything about it, and then fly it, and then report the flight parameters, what were the problems you were encountering, and so on and so forth. Okay, so let's talk about the flight simulator that we are going to use. The flight simulator is a very comprehensive flight simulator. There are other flight simulators. One of the most famous ones out there is the Microsoft Flight Simulator. But the reason we use this one is because we can easily export the flight parameters out of the software. So it has an educational purpose as well. As I said, it's a great tool to analyze flight parameters. And in this course, in general, whenever we are talking about an aircraft, we are talking about Cessna 172 or different types of Cessna 172. As I mentioned, we will learn how to fly with Cessna in the lab, and we want to track the flight parameters, we want to export flight parameters, and then we want to compare the flight parameters between the two types of, between the modifications. So essentially, for the lab, you have to make one modification. Actually, it's not bad. This is a picture of Cessna, and I just want to make sure that you have a record of this. You have to make one modification to the aircraft, and this is for lab 2. Modification to the Cessna, just one. Before making that modification, you have to say why. You have to explain why you are making that modification, and what do you expect to see. Let's say you are changing the aspect ratio, making the wings longer or smaller, and then you have to know what will happen if you do that, and then what will happen to lift coefficient, drag coefficient, lift to drag ratio, and so on and so forth. And then you have to compare the CL versus alpha, CD versus alpha, and lift to drag ratio versus alpha, and also the drag polar for the two cases. You just compare this for the two cases, and you write a conclusion in your lab report, and you say whether this has met your expectations or not, or you were wrong in predicting the effect of whatever you wanted to, whatever you thought may happen. And keep in mind, I want you to make a prediction before going in, so we will record your predictions in the lab. And if you were wrong in predicting something, that's all right? There is no problem. You won't. No point will be deducted because your prediction of what's going to happen after you modify the aircraft was wrong. Nothing, no point will be deducted about that. So I just want to make sure that you understand yourself whether you have a good understanding on the effects of, I don't know, aspect ratio, sweep angle, on all of those things on the aircraft. This will give you a better idea. Okay, so yeah. Okay, so the first step in the lab is to learn to fly with Cessna, which is lab 1, right? And learn how to enable the data logging. So far, you have become familiar with the axis of movement of an aircraft. We have talked a little bit about the stall conditions and its effect on the lift coefficient, which you have seen in your aerodynamics course in detail as well. And I'm sorry, this is lab 1. And you also have become familiar with different terms we use, with different functions of different parts of aircraft, like the rudders, elevators, and the flaps. So we have already covered those things in the lecture, but what you're going to do is you're going to try to control them in a simulation of the real world flying, actually. Okay. So the second step, which is going to be part of lab 2, is to modify the Cessna parameters, just one parameter for this case, right? But for your final presentation, you essentially have to create an airplane from the scratch, right? Not literally, but I mean, you have to change the Cessna so much that it becomes a new aircraft. And for every modifications you make, you have to have a justification. And by justification, I mean you have to know what's going to happen when you make that justification, right? You have to know what's going to happen as far as the lift and drag ratio goes, and what's the benefit of that happening, right? And the benefit of something happening can be like it will improve the landing, it will improve the takeoff, it will help us carry more load, right? Because Cessna is a very small aircraft, right? You may want to like increase the cabin size. Instead of like 6 passengers, you may want to have 20 passengers, right? So on. So you can choose whatever reasoning you want, and then based on that reasoning, make a modification. You may wanna change the Cessna to a passenger aircraft in general, right? Instead of a leisure aircraft. And yeah, we will talk about your final presentation, but your one parameter that you want to change, it should be a very simple thing. You just want to make sure you understand the parameter. Then you rerun the flight simulators to be able to compare the two flights. But how can we modify the aircraft parameters? We are going to use a software that was developed by the creators of X-Plane, which is our main flight simulator, called the Playmaker. The Playmaker is actually a bundle, come bundled with X-Plane, and keep in mind that if you wanted to work on this at home, you can download X-Plane. Let me write it down. You can download X-Plane for free from its website, and it comes with the Playmaker software and another software which we'll talk about later on called the Airfoil Maker. Okay. It already comes with those software, so you don't really need to worry about the fact that because of the COVID situation, you may not have access to the flight simulators or the computers in the computer lab, because you can download it on your own computer and like play with it. But X-Plane is a very heavy software. It requires a lot of computational power. So I don't know if you can run it on your laptop, but you will definitely be able to do the modification on the aircraft on your laptop. That should be pretty easy. It doesn't require that much of a computational power. Okay. I have included these two links here that are essentially data references in X-Plane. That let's say you wanna, let's see if we can go to the links here. Let's say you wanna uh, let me close all the windows I already have and open a new one. Let's say you want to read, I mean, we're gonna see all of this in the lab. I will probably do a demonstration lecture for you as well, so you can always have a recording of it. But that link gets you here. That essentially tells you that the type of the data you're going to read. There are two different types of data we're going to see in the explain. One of them is easier. This one that you're going to see is the harder one. And this is essentially a guide to what those data are. This essentially gives you the control on every inch of the airplane. You can read the data anywhere. If you get an output for Girin LOEGT, it's a float number And that's a computation. I'm pretty sure you are familiar with float and integers. There was a, let's go with this one, EPR, right? It will give you a ratio, and it's essentially the engine pressure ratio, right? And you don't need to know all of them. You can just search here for lift. Let's see what are the options for lift. So we can have these two type of lists. Let me search for CL. Yeah, it will give you the lift coefficient over different parts of aircraft, and also it will give you a total lift coefficient. A lot of different lift coefficients that you can choose. The same is true for the drag coefficient. The same is true for all other parameters. And this part, this is actually for the curious among you. And if you do this, I will actually will definitely give you a lot of bonus points. Okay, so if someone can make this happen, and we did this happen, we actually made this happen, and last year people took benefit of the thing that I'm going to explain right now, but they didn't write the code themselves. So what you can do with the explain software, I think let me write this down for you guys. What you can do with the explain software, okay. Let me clear this canvas. Yeah. What you can do with the explain software is actually you can read the data over a network as well. Okay. So let's say you have the flight simulator. You can connect a network cable to it and read the data in another laptop. We have the laptop. We can give you the laptops that you can use. You want to use for this connection. We also have the network cables. It's pretty simple, the connection part. But you can actually ask the explain software to send the data over network to this computer, right? And then you can write a Python code or a MATLAB code, whatever you're more familiar with, and read the data here and monitor the data in another computer real time. So this way you can actually ask someone to fly the airplane in the lab for you and sit at home and read the data at home, or sit in another class and read the data at home. The only thing you really need is a very simple Python and MATLAB code, which is already given in this here. They already give you the code and everything. You just have to get it to work. That's it. And all you probably need to add some things on, like a real time. What I did for the code that I wrote last year for this course, which is not going to be part of the requirement of the class. So this is not a requirement. This is just a bonus thing. And if you do, we will essentially let you, if you write a code and can connect this explain, I will let you I will essentially ask you, it will cover, sorry, I was looking for it. So writing the code will cover 3 lab reports or 3 quizzes, whichever works better for you. Let's make this 4 quizzes. No? I think lab reports are worth more than the quizzes, right? So you can choose. If you write the code, if you make the connection, if you can show me your code works and can track, that's the most important one. It should be able to track the flight parameters in real time. So what I mean is it should be able to output a lift to drag coefficient versus time. Let's say you have the y-axis in a in a window, right? Something like this, CL versus time, your code, and it also need to write a CL versus alpha, and also the time in a Word file or in a text document, right? Whatever kind of text. So if you can do this, you can go ahead and do this. I'm definitely fine with it. I will give you, and this will cover if you can get it to work. If you want to do this, please reach out to me and I will explain this a little more to you. Okay, so let's move on. At this point, you are familiar with the software. I've also included the manual for the two softwares that I mentioned, the Airfoil Maker and the Playmaker for you guys. So with the Airfoil, the difference between the two softwares, Airfoil Maker and the Playmaker, is that for the Playmaker software, you essentially end up designing the whole aircraft. And this is the software we are going to use mostly. And we will go over it. The next lecture is going to be focused on how to work with the software, how to change the parameters. I think it will be part of this lecture as well. But if you have the time, yeah, it will be part of this lecture as well. But the airfoil maker part is essentially, let me actually put this here. It is essentially two-dimensional, as it is very apparent from its name. It's a two-dimensional designs software, if you will, in which you can change the airfoil, just the airfoil parameters. You can change the type of the airfoil, you can actually change the camber, you can change the chord length, you can change a lot of parameters of the airfoil. And then when you can actually design a new airfoil, you can go to the Playmaker software if you were to design a new aircraft and tell the Playmaker software to use this new airfoil that I have designed, right? So that is the idea. So essentially, if you were to design a new aircraft and if you want to design a new airfoil, this is how you test it, right? You go to the airfoil maker, you design the airfoil. Over there, very simple design. You just create your aircraft, or you use one of the older aircrafts, like, I don't know, Cessna, whatever, and tell Cessna to use this airfoil instead of the airfoil that is already installed on it, and then you can test it. And this like, let's say you are a design engineer. This is something you can do in your job actually, and this is a free software, so you can always use this. Like the Cessna part, a lot of it is free, so you can just have it on your computer. Okay, and I have the manual of the software listed here for you. It explains everything. It's a very comprehensive manual, and it's a text file, so you can always like bookmark it or save it and come back to it. But we're not gonna in the lab. We are not gonna go over this because it's gonna take a lot of time and it needs a little bit of like mathematics, right? You must be able to analyze and understand the airfoils, which I think you already have learned in your aerodynamics class, hopefully. Okay. So let's go over the Playmaker. The next parts of the lecture is going to focus on the Playmaker software. So the first thing we want to do is want to become familiar with the different terms that is used in the Playmaker software, right? And afterwards, in the next lecture, we'll get to work with Playmaker. Of course, if we were in a class, that would have worked better because over there you could have asked your questions from me. But in the lab, it's gonna be hopefully we're gonna meet in the lab, and over there you'll get to play with the software. We're gonna stay a little longer so you guys can ask any questions you may have. Me and my TA, both of us. Your TA is also pretty familiar with this already, and yeah, you can ask your questions over there. But let's start with the playmaker, how to work with the playmaker essentially. The first part of the playmaker workflow is that you have to decide on a design, and that happens outside of playmaker. As always, with any design parameters, you have to brainstorm and you have to understand what you want to do before jumping into the software and designing whatever you want designing. And then afterwards, the next step is manufacturing, which we don't have in the lab 1 and 2. Okay. If you were to design an aircraft from the beginning, you had to create the fuselage first, right? And then you add the wings, tails, and so on and so forth. A playmaker actually gives you the ability of adding the secondary objects because you can, as I said, you can using the playmaker, you can design an aircraft from scratch and add any detail you want to add to it, and then you can fly it. Of course, if you don't add landing gears, you won't be able to fly your aircraft in the X-plane flight simulators because it won't be able to move on the runway, right, on the tarmac. And you can also add different types of engines with different horsepowers and so on and so forth. Then the next part, which is the non necessary part of your design, as far as the your goal here, which is being able to fly the aircraft goes. This is a non-necessary part, right? This is the luxury part. But if you were to design a real aircraft, these are very important as well. So, okay. So, which is setting up the system and internal properties. Oh, the engine part is very important. This is not what I meant. Sorry. This is what I meant is the luxury part. Okay. So the third point is very important. You have to design it. You have to add these things definitely before being able to fly. And but the last part, I mean, you can of course add weapons or any special controls. You can add windows, whatever you want to add to the aircraft. It's actually that part is pretty fun. So I recommend you play with this in your real time because that's pretty fun. The next part is to create a 2D instrument panel, and afterwards we'll test fly the aircraft in X-plane, and if everything didn't go as you planned, you have to fine-tune the features and you have to repeat these steps again and again, which I think you're gonna do a lot of this testing for your final presentation, right? Because you want to make sure that you are adding something to the design, you are making it better, right? Yeah, that the last part is also optional. This is a sample view of the Playmaker software, which you are going to see when you export an aircraft. You can see it gives you a lot of controls over a lot of things. It gives you controls that is essentially everything. The ailerons here, the roll spoilers for this specific aircraft, elevators, and you can add this if you were to design this aircraft from scratch. You can add any of these that you want to add here, right? You can see you can control different wings and slabs and stabs on the aircraft in different tabs, and then you can actually control the different characteristics of that specific part of the wing. Okay, let's say you are telling that this wing 3, has the aileron and a slat. We'll go over this in details, but essentially you are going to give it the root to tip length, and then you are going to give it root chord, tip chord, swoop angle, whether it is dihedral or anhedral, or does it have any angle in that region, and so on and so forth. Okay. Something that you have to keep in mind, and this is very important when you are changing the design parameters, is the axis of the of the main axis of the movement of an aircraft. We have the lateral, vertical, and the longitudinal axis. Just have to make sure that you understand what is the positive value in the Playmaker software and what is the negative value in the Playmaker software. For the longitudinal arm, a positive value is behind the reference point. So in this direction, this is a positive value. And a negative value is forward the reference point. Okay, so this is going to be positive, negative, right? And for a longitudinal arm, for the latitudinal arm, which is the lateral line, right? Right of the reference point is gonna be positive. So this direction is gonna be positive, and left of the reference point is gonna be negative. Okay. And the same is true for the vertical arm. Not the same, but you have to be mindful of the vertical arm as well. Above is the positive, below is the negative. Okay. So when you're adding the design, let's say you want to move the aileron in the positive direction, you want to move it forward, right, from the reference points, you have to add a negative value to it. Okay. It actually depends on the design. If this is a rotated design, then you have to add a negative value to it. If this is not a rotated design and they have designed everything in the other direction, then this is a positive value. I hope that makes sense, but I'm pretty sure you'll get the hang of it. It's just you just have to play with it a little bit. And let's do the glossary of the terms. And afterwards, this is going to be the first lecture of the lab 2, essentially. And for the next lecture, we will go over the Playmaker software. We will try to explain it a little bit so you can get a hang of it. The lectures for this week are going to be very short because it's mostly focused on the lab 1 and lab 2. But from the lab 3 lecture, it is going to be a little more mathematical, a little more theory based. And as we get to the mechanical properties testing, like the torsion, the bending, and all of those, it is going to be get a little heavier. The lectures are going to be a little heavier. You just have to make sure you follow the loop. That these first 2 weeks has been pretty easy. I think, hopefully, not all of the class is going to be like this. Some parts of it is easy, some parts of it is hard, so you just have to be mindful of that. Okay. So the ACS, the glossary of terms, you have to deal with a lot of .acf files, and .acf is actually like .exe files in Windows, which are executable files. The aircraft files that you can use with explain are the .acf files. You just have to put them in the appropriate folder, and you should be fine. Keep in mind that I will probably send you some links, some YouTube videos that have explain and Playmaker software better than me, so that those are worth going over as well. Yeah, make sure you follow them. Anyway, I've talked about these terms before. Just a reminder, ailerons are the control surfaces mounted on an airplane's wing, which move in the opposite direction to roll the aircraft. Right? That's one of the most important parts of the ailerons, right? Airfoil is the cross-sectional shape of a wing. So airfoil is always a two-dimensional thing. Different airfoils have different lift and drag properties at different speeds and angles of attack. Aspect ratio is the ratio of a wing's length to its chord width. A low aspect ratio results in short, stubby wings, while a high aspect ratio results in long and narrow wings. And you just have to, I probably ask you this question when we meet in the lab, but if we were in a real class, I would have asked you this question: what's the difference between a low aspect ratio and a high aspect ratio as far as the flight parameter, flight properties goes, what does it affect the aspect ratio? What is the main effect of the aspect ratio as far as the flight parameters goes? Blade pitch, which refers to the propeller's blade. It's the propeller's angle of attack, which is the angle at which a propeller meets the air. Variable pitch propellers are able to rotate the propeller's blade along their longitudinal axis, which means that they are going to change their pitch, right? And the chord is the line connecting the leading edge of an airfoil to the trailing edge of an airfoil. A representation of airfoil. I'm pretty sure that you are familiar with most of these terms, but I have to go over them anyways. Just a reminder, if you guys are familiar, so bear with me with this part. For an airfoil, we have the leading edge, which is the first point of an aircraft that meets the air, the upcoming air. We also have the trailing edge, which is the point where the air leaves the airfoil, essentially. And we have, if you recall from your aerodynamics, we had the cutoff conditions. Cutoff condition at the trailing edge, where the velocities had to be equal or zero, right? So we either had to have a stagnation point or equal velocities. We have the thickness of the aircraft, which changes as you move from the trailing edge to the leading edge. The chord length is the shortest distance between the trailing edge and leading edge, that's between the LE and TE. We also have the camber, which gives you every point of camber has the same distance from the upper part of the airfoil and the lower part of the airfoil. And camber is a very important property in an airfoil design. The upper parts of the airfoil are called the upper camber, the lower parts are called the lower camber, and the angle of attack is the angle the airfoil makes with the upcoming air. Talked about this. There's another angle that relates to wings. It is called the dihedral or anhedral angle, depending on that. They are called the dihedral and anhedral wings, depending on the dihedral and anhedral angle. Let me write it down. Anhedral. Okay, so the dihedral angle is the upward or downward angle of the wings when viewing the aircraft from the head on. So we have the head of the aircraft here. When we are viewing it from a front view, and the angle it makes with the horizon is gonna be your dihedral angle. We can also actually have this type of angles as well. Let's call it A, which is going to mean your wings are going to be anhedral. There are different properties to the dihedral and anhedral wings. Hopefully you have gone over them in your aerodynamics course. If not, we will go over them in a little more detail, not that much, in the flight and orbital mechanics course. Okay, we have the elevators of the aircraft, which for this specific aircraft are here, that are control surfaces mounted on the airplane's horizontal stabilizer. Elevators are always part of the tail, which moves together to change the pitch of the airplane. You may ask, why are the elevators part of the tail? That has a pretty simple explanation. You want to make sure that you are giving it the maximum amount of moments to the lower part of the tail as far as the center of gravity goes, so you can pitch up or pitch down, right? With the lowest amount of force, right? If your elevators were installed on the wings, then the amounts of force you needed to pitch up or pitch down would have been much higher because the moment arm would have been much, much lower. If the center of gravity was like on the wing or even ahead of the wing, right here. But if the center of gravity was here, your work would have been much more complicated, right? But yeah, you needed a lot more force. So the reason we have moved it to the tail, the elevators, is because we want to decrease the force needed to pitch up or pitch down, to control the pitch in general, right? We also have the flaps that are control surfaces mounted on the trailing edge of the wing, which is extended in order to lower the airplane's stalling speed and increase the drag acting on it. This is one of their functions. You probably at this point know about other functions. We also have the incidence angle, which is an important angle as well. That's the incidence of the wing. That's the downward or upward angle of the wing when viewed from the sides, right? So exactly this view. When you are looking at this view, if your wing was in the same direction as the horizon, then the incidence angle would have been 0. But here in this case, it is not in the same direction, so we have a positive incidence angle. And in the lab, I will probably ask you, what does the incidence angle do? What does this angle do? So you just have to make sure that you know what this does and you are able to answer my questions. Okay, there is this term called livery, which is a certain paint scheme for an aircraft. Different liveries can be selected in explain or not the explain itself. The planemaker software is actually, as I mentioned from the beginning, will give you the ability to create an aircraft, a complete aircraft from the scratch. But this is actually pretty interesting. We also have the pylons, which is a hard point on the aircraft where things like engines and weapons can be mounted. These are called. This is actually this red area is the pylon of an aircraft. This should have been an animation, but they are not. So we have the reference points. These are some of these are only for the Playmaker software, like the reference points. This is an arbitrary point of the aircraft, around which nearly all objects position are set. Right? We have the root of a wing, which is a part of an aircraft wing, which is closest to the fuselage of the aircraft. We have the rudders, which are the control surfaces mounted on the aircraft vertical stabilizer. They are mounted on the tail for the same reason that we discussed, which move in the opposite direction to change the yaw of the aircraft. We have the slats, which are the control surfaces mounted on the leading edge of a wing that extends to allow the aircraft to operate at a higher angle of attack. The slats are very useful near the stall tips. We had the speed brakes, which are the type of flight control surface used on an aircraft to increase drag, to increase the angle of approach during landing. Which means that their main job is to decrease the speed of the aircraft when landing, right? And I'm pretty sure you already know what the standard atmosphere is. 1 atmosphere air pressure. And we also have the sweep angle, which for some reason people like to change the sweep angle the most, like to modify the sweep angle the most. The students I have worked with so far, which is the sweep angle is the angle forward or backward that wing points. So when you're looking at the airplane from the top, the angle it makes with the horizon is going to be the sweep angle. So here we have the sweep angle. Okay. And the last thing we want to discuss is the tip of the wing, which is very self-explanatory. We're talking about the part that is furthest from the fuselage or the body of the aircraft. So this is it for today. The next part of the lecture, or the lecture 2, as it relates to the lab 2 of the class, is going to be the playmaker. So we are going to go over the playmaker, how to design everything, but I will also post some YouTube videos that will help you understand the playmaker, that are tutorial that goes into more detail. You're always, let me finish by saying this. So during this lecture, I gave you two options. I gave you one option so far. I've given you one option to make the connection between two computers as far as the explain software. So explain can talk, explain on one computer can talk to another computer over the web, right? And export the data, monitor the data. If you can do this, if you want to, if you're willing to do this, you have to let me know, right? You have to send me an email, or you have to talk to me during the first lab, which is going to be on Tuesday. So in 2 days, right? 2 days from the day that I'm recording this video. This is going to be September 1st, I guess. Yes. And yeah, you have to let me know, right? And if you do that, we will set a deadline for it. If you do that, you don't need to take 4 of the quizzes, or you don't need to submit 3 lab reports. I would rather if you don't take 4 of the quizzes, if you do this, because lab reports are very important to the course, are very crucial. So yeah, but you always have the option. The other option that I can give you is to design an aircraft instead of for your final presentation. We will talk about these in the lab. I will make sure to answer any questions you will have. But your final presentation, if you do what the other students in the previous class did, like you can design the aircraft from the scratch instead of just modifying just a heavy modification of a Cessna from scratch. You can call it whatever. You can call it your name, aircraft, right? Whatever. It's gonna be your aircraft. If you design an aircraft from the aircraft and you add whatever you need to add to it, and you add all the niceties. So give me a complete painted aircraft that we can submit to the explain repository. So a complete aircraft. I can actually give you relief essentially on. I think we have a total of 7 quizzes. So 3 more quizzes, essentially. So if you do these 2, you don't need to take any quizzes. I think that's a pretty sweet deal. And yeah, it's gonna help you become familiar with the programming a little bit, just a little bit, very small, right? But also it will help you understand the designing of an aircraft and the complexities of the design of an aircraft a little better. So we will talk about these 2 options in the lab when we meet on September 1st. And yeah, I will give you these 2 options. Yeah, I would rather you guys do like projects work more than just taking an exam or a quiz. So whatever opportunity I can give you to do that, I will be happier. If you have something in mind, if you have, you can also always keep that in mind. With me, in every course you have with me, which as aerospace students you will have a lot of courses with me, right? Whatever opportunity or whatever proposals you come up with that is related to the topic of that specific course, like to do a project, I'm definitely up for it, right? For example, if in this project you come up to me and say, hey, Dr. Mobley, I wanna design a new composite, right? I'm pretty sure at this stage of your career, at this stage of your education, you don't know how to design a new composite, but that's all right. That's what you're here for, right? And I have, like, if you tell me that I've talked to the McNair people or whoever, I've talked to Dr. Herrick, and I have this idea. He's going to give me the material. I want to work on it. I'm gonna do this like mechanical testing. I want to do that. I want to do the torsion test. I want to do whatever. I want to do all of these tests on it, and I will write a full report. I will tell you that go for it, and it will cover the whole course for me. So yeah, this is very important for me. That understanding of that essentially design and analysis aspect of any course. I'm pretty sure that will give you a better understanding. So if you had something like that in mind, please reach out to me. I'm pretty open to ideas, but it just have to be a real proposal, right? You just have to tell me that you really want to do something. Okay, so that's it for today. I will post this online as soon as possible. And yeah, have a good day.